The concept of the atom is actually an ancient concept. Democritus had proposed that at some point, if you subdivide a pure material down, there becomes a point where you cannot divide it any further. And he proposed that we call the atom the smallest indivisible particle. "2,000 years later, Dalton codifies these things and says that elements contain just one type of atom, and that different types of elements contain different types of atoms. So that a sample of gold contains only gold atoms, and a sample of copper would contain only copper atoms. That atoms cannot be interconverted. So if I had a sample of copper atoms, there would be nothing that I could do chemically to convert those atoms into being gold atoms. That atoms, when they combine in whole number or integer ratios, and that atoms cannot be created nor can they be destroyed. That essentially the number of atoms that are on planet Earth today is the same as it has always been. Well, the concept of the atom being the smallest indivisible particle went away in the 20th century when we discovered that there are three major subatomic particles: the proton, the neutron, and the electron. The electron was the first one to be discovered, and here's a diagram of essentially Thomson's experiment, where we know that if you have two pieces of metal and you put a very large voltage between those metals, that you can create a spark that goes from metal to metal. Well, if you encase that in a vacuum tube, you can actually pull the metal plates apart from one another, and then a beam of light is emitted from one plate and goes to the other. This is called a cathode ray, and cathode rays are strange. They're strange in that although they appear to be beams of light, because they travel in straight lines, they cast reflections, they do the regular wave behavior that light has, they also do a couple of other things that are a little strange. If you put a piece of gold leaf in this beam of light, the gold leaf would be dislodged when the light hits it. This means that this beam of light contains mass, and the beam of light, the cathode ray, can also be deflected in the presence of a magnetic field. So there's something extra going on. And this beam of electrons, it turns out, the electrons are highly excited and are leaving one metal plate to go to the other, are charged particles, and they have mass and particle behavior, but they also have wave behavior as well. There'll be more about that later, not in this lecture. Milliken did a fantastic experiment in which he took little droplets of oil and irradiated them, and then had them defy gravity by being repelled by an electric plate, so that he could measure what the charge of an individual electron was. Later on, protons were discovered by Rutherford, and much, much later on, and there's a reason why the neutron is the last subatomic particle to be discovered. Neutrons were eventually discovered by Chadwick. So, we have three major subatomic particles. There are more. There are questions about, well, what are the if atoms are made of protons, neutrons, and electrons, well then what are protons made of? And that's a valid question if you're a physics major, but for chemists, we're going to spend our time really looking just at protons, neutrons, electrons. And it's going to be the electrons that are responsible for chemistry. So that's where our emphasis is going to be. Protons are the subatomic particles that have a positive charge. Electrons counterbalance that by having a negative charge, and neutral atoms actually should have an equal number of negative electrons and positive protons. Protons and neutrons have essentially the same mass. It's slightly different. And the mass of an electron is significantly smaller than either the proton or the neutron. So almost 1/2000th the size. Protons and neutrons can be found in a different part of the atom than electrons are. So, now that scientists knew that the atom contained these different particles, they postulated that, well, maybe they just all coexist inside the spherical atom. And of course, an atom is a sphere because the sphere is nature's little perfect way of creating the most amount of volume for the smallest amount of surface area. So this plum pudding idea was that all the particles just belong together. Well, actually, it's significantly different than that, and it's much more ordered. Rutherford was doing an experiment where he was expecting a piece of gold film to diffract his alpha particles. Alpha particles are a type of radiation. And diffraction would be when the beam passes through the gap between the gold atoms, that gap would be so small that the beam would be deflected. But what he actually found is that, yes, he got the data that he was expecting, but he also found that the particles bounced off that very thin metal film, which is something that was unpredictable. And what that means is that there is something hard inside the atom that the radiation was bouncing off. And that led him to postulate that the center of the atom contains a very hard mass that we're going to call the nucleus. So if this diffuse circle right here represents the size of an entire atom, then this little speck inside represents the nucleus, and the nucleus contains the protons and the neutrons, which, you remember, is almost all of the mass of the atom, and the electrons are going to orbit the nucleus, traveling in pseudo-random orbits, much more on that later, at approximately the speed of light.